Hi guys, and welcome to the third installment of our flipped classroom. We've already looked at polygons and angles, perimeter and area, and tonight we're going to look at the surface area and volumes of three-dimensional shapes. Just as a reminder, I want to show you the formula sheet that was given to you today, or yesterday if you're watching this tomorrow. It's got the surface area and volume for the following 3D shapes. We have a cylinder, sphere, cone, square base pyramid, rectangular prism, and triangular prism. So it's worthwhile for you to take a look at this sheet just to make sure you understand what it's showing you, because it does break up, especially in the surface area category, it breaks up all the surfaces of the 3D shapes into their separate formulas and then puts them together. To start off, we're going to talk about the surface area. As an example, we're going to use the cylinder. The area that the cylinder covers of a 3D figure can be shown by a net. And this here is what a net looks like, where it breaks it up into the two shapes. You've got two circles at the top and at the bottom. Then if you take that lateral area and cut it and roll it out from its cylinder shape, you end up getting this rectangular shape. So you have the two circles, and finding the area of those should be pretty easy since the area of a circle is pi r squared, and you've got two of them. Then for the rectangle, the width is going to be that height of the cylinder, which is 20 centimeters, and the length is going to be the circumference of the circle. So if you notice here in the red, I've got the red on top here circling the circle. It's the same length if you roll it out as the length of your rectangle. Okay, so if you were to solve this, you're going to add up all of these areas. So area of the circle, area of the other circle, and then area of the rectangle will all be added together. The two areas of the circle, since they are both the same size, can be written as 2 pi r squared as opposed to separating them out with pi r squared and pi r squared. Substituting your values that you're given in the question, it's just basic algebra manipulation at this point. I get to give you your answer. The surface area that covers a triangular based prism. So again, you've got three rectangular surfaces, and that's what the AH, BH, and CH in the formula sheet is showing you. So you've got this surface, this one at the back here, as well as the one at the bottom. So those are your three rectangular shapes. And then you've got the two triangles at the front and the triangle at the back, okay, which are going to be exactly the same. So if you take a look, it's half the base times the height for the area of those triangles, but since it's multiplied by 2, that's why there's no half part in the area total equation that's on the formula sheet. So using your equation and substituting all these values in, you find the area of each of those rectangles. So you have those three rectangles and then the area of the two triangles together, giving you 685 meters squared. Okay, so make sure you need to calculate all the sides. Sometimes with word problems, they leave out the back or they leave out one of the sides. So make sure as soon as you see a rectangular prism, you don't necessarily go to the total formula, and that you actually take a look and see what the question's asking you to find. For instance, in this question here, we have this cone that's been chopped off. So the part that remains is what we're going to end up calculating, the two circles, so the top and the bottom. And then when you roll out that lateral surface area, before when we had the cylinder, it was a rectangle. When we roll this out, we're going to end up with a trapezoid. So I've denoted each of those circles with a small r and a capital R for the radius, just to denote that they are different. And then the trapezoid is calculated by a plus b times h divided by 2. Each of those a plus b needs to be calculated using the circumference of the circle. Remember, the same way we did with the cylinder for the rectangle. So 6.283 was calculated by finding the circumference of that top circle, and 25.133 was calculated from the bottom. Lastly, I just quickly want to go over a volume question. With these 3D shapes, it's very similar. Volume equations actually are the easiest of the two for surface area and volume, in my opinion. So I have the volume of a cone being denoted as 1/3 pi r squared h. So if we take a look at the solution, we can just input the values that were given. The radius is 20 centimeters, the height is 60 centimeters. Inputting it into our equation, we end up getting our volume of 25,132.7 volume centimeters cubed. Again, remember, for volume, your units are centimeters cubed. So that concludes our take a look at surface area and volume of 3D shapes. The following questions should be done tomorrow in class, and I'll see you then.